Hello everyone, welcome back to my YouTube channel. As you all know me, I am Ruchi HP, the student of Sri Venkateshwara College of Engineering, Bangalore, from the Department of Computer Science and Engineering. And the today's subject is Analysis and Designs of Algorithm. And today's my topic is Brutal Force Approaches, Sorting Techniques. Table of Contents, Introduction to Brutal Force Approaches, What is Selection Sorting, Algorithm, Step-by-Step Explanation, Example, Time Complexity of Selection Sorting, Advantages and Disadvantages of Selection Sorting, Conclusion. Introduction to Brutal Force Approach. Brutal force approach involves solving the problems having by trying all the possible solutions until the correct one is found. This exhaustive method is simple to implement but can be computationally intensive and especially for large-scale problems. What is selection sorting? Selection sorting is a brutal force algorithm that works by iteratively finding the minimum elements from the unsorted part of array and swapping it with the first elements of the unsorted part. This simple approach results in an inefficient sorting methods. Algorithm. Selection sorting array of A 0 to n minus 1. Sorting a given array by selection sort. Input an array of A 0 to n minus 1 of orderable elements. Output array A of 0 to n minus 1 sorted in non-decreasing order. For I is equal to 0 to n minus 2, do minimum is equal to I. For j is equal to I plus 1 to n minus 1, do if a of j is less than a of minimum, then minimum will equals to j. Then swap a of I and a of minimum. Step-by-step explanation of selection sorting. Step 1. Dividing the array into sorted and unsorted parts. Starting with the entire array of an unsorted parts. Step 2. Find the minimum element in the unsorted part. Iterate through the unsorted part and keep track of the minimum elements. Step 3. Swap the minimum elements with the first elements of the unsorted array. This moves the minimum element to the sorted part of the array. Step 4. Repeat the steps 2 and 3 until the array is sorted, gradually increasing the size of sorted part and decreasing the size of unsorted part. Example, unsorted list 52143 and the number of elements n is equal to 5 and the array size will become n minus 1. 5 minus 1 is equal to 4. First iterations, a of 0, the smallest is equal to 5, 2 is less than 5, so smallest is equal to 2 and 1 is less than 2, the smallest will become 1. 1 is less than 4 or 4 is greater than 1, then smallest is equal to 1. 3 is greater than 1, here the smallest is equal to 1. So we are swapping 1 and 5 and the list will become 1, 2, 5, 4, 3. Second iteration, the smallest is equal to 2, a of 1 is equal to 2, 2 is less than 5, the smallest is equal to 2, 2 is less than 4, then the smallest is equal to 2, 2 is less than 3, then smallest is equal to 2. So there will be no swapping and the list will become 1, 2, 5, 4, 3. And third iteration, the smallest will be 5. A of 2 is equal to 5. 5 is greater than 4. The smallest is equal to 4. 4 is greater than 3. So the smallest will be 3. So we have to swap 5 and 3. And the list will become 1, 2, 3, 4, 5. Fourth iteration, A of 3 is equal to 4. Then smallest is equal to 4. 4 is smaller than 5. Then the smallest is equal to 4. Then there will be no swapping. And the list will 1, 2, 3, 4, 5. And then the final sorted list will 1, 2, 3, 4 and 5. Selection sorting. The original sort is equal to 5, 2, 1, 4, 3. And the first iteration we will swap 1 and 5 and it will become 1, 2, 5, 4, 3. Here 1 will be sorted. In second iteration there will be no swapping. So 1, 2, 5, 4, 3 and the 1, 2 is sorted. In third iteration we will swap 5 and 3 and the list is 1, 2, 3, 4, 5. Here 1, 2, 3 is sorted. In fourth iteration, there will be no swapping. Here 1, 2, 3, 4, 5. Here 1, 2, 3, 4 will be sorted. And here 1, 2, 3, 4, 5 is finally in sorted list. Time complexity of selection sorting. Best case, O of n to the power 2, where n is the size of the array. In average cases, O of n to the power 2 as an algorithm performs the same number of comparison and swap regardlessly of inputs. Worst case, O of n to the power 2 as an algorithm perform the same number of comparison and the swap regardlessly of inputs. Advantages and disadvantages of selection sorting. Advantages: simple to implement and understand. The performance of a same number of comparison regardlessly of inputs and requires only a constant amount of additional space. Disadvantages: insufficient for large datasets as it has a time complexity of O of n to the power 2, making it unsuitable for sorting large arrays. Conclusion: selection sorting, a brutal force approaches. The selection sorting is a simple brute force algorithm that iteratively finds the minimum elements and swap it with the first elements of unsorted part. Here with time complexity, the time complexity of selection sorting is O of n to the power 2, make it insufficient for large data set. However, it requires only a constant amount of additional space. Advantages and disadvantages. The selection sorting is easy to understand and implement, but its inefficiency for large arrays limits its practical uses in real-world scenarios. Thank you. Thank you for watching this video.